Big surprise, we're being asked to find the equation of another tangent line. The way we do that is by finding a point and a slope. Now, fortunately, we're already given the point. The last thing we need to do is find the slope. Now, how do we find the slope? That we find using the derivative. Unfortunately, the derivative of this function is going to be a little bit more complicated because I have a jumble of x's and y's all inside this equation. So this is where implicit differentiation comes in. This is where I'm going to use this guy here. I'm going to take the derivative of both sides. The one important rule to remember is that anytime I take the derivative of y, I tack on dy dx. So the derivative of y squared would normally be 2y, but because I took the derivative of y, I tack on a dy dx. The derivative of x times y is going to require the product rule, so I'm going to do minus some parentheses. The derivative of x we're going to leave alone, or sorry, let's say the derivative of x is 1, while leaving the y alone. That's going to give me 1 times y. And then I'm going to say plus, and now I'm going to take the derivative of y, leaving the x alone. Let's leave the x alone. The derivative of y would be 1, except don't forget, the derivative of y is dy dx. Okay, and then we have the derivative of 8, but that's just 0, so that all goes away. The derivative of 0 on the right-hand side is also 0. Okay, so now I have this expression. I want to collect all the dy dx terms to one side, all the non-dy dx terms to the other. So that means I'm going to actually, one last thing, let's distribute this negative to the inside. So I have minus y minus x dy dx. Okay, I'm going to add this negative y over to the right side, leaving me with 2y dy dx minus x dy dx equals y. I'm going to factor dy dx from this left-hand side from the 2y minus x. And then I'm going to divide both sides by 2y minus x, giving me dy dx equals y over 2y minus x. This is my derivative. That derivative I'm going to use to figure out my slope. Now, keep in mind, my derivative doesn't have just x in it as it used to. It has x and y. So when I plug in 2 for x and 4 for y, let's see what I get. I'm going to get 4 over 2 times 4 is 8. 2 goes there. 8 minus 2 is 6, so 4 over 6 is 2/3. So this is my slope, 2/3. With a point and a slope, I now can make a line. We're going to say y minus 4 equals 2/3 times x minus 2. And I can distribute and move things around. Let's go ahead and do that. Y equals 2/3 x minus 4/3, but then plus 4, that's 12/3. 12/3 minus 4/3 is 8/3. And so that is my final answer.